This is number 42 from section 5.5 in the Stewart text, integration by substitution. And this is a good kind of a classic substitution problem. You have a composite function, right? You have a one function inside of another function. In this case, we have the cosine of t inside of this secant squared of a function, right? And on the outside here, we have the sine of t. And so there's a couple clues in here as to a good substitution to start with. Let's just say u equals, and a lot of times it's good to have your u equal the inside function. So in this case, cosine of t. And again, the idea is that the substitution undoes a chain rule. So if you let u equal the inner function, then your du will have the derivative of that inner function, in this case, negative sine of t dt, which, if you were taking a derivative of this whole thing or something like this, you would have to take the derivative of the inside last, right, of a negative sine of t. And so that's where the chain rule comes in. That's what this substitution does. It takes care of that chain rule first. So anyway, good rule of thumb, let the u be the thing inside of the other thing, and then your du, you have to get the du, right? If you're going to change to u, then you have to change the dt to a du. And so we have the secant squared of u, but then we also have this sine of t dt. That's going to become our du. All we need is a negative, right? We need it to be negative sine of t dt. So what I like to do is just kind of throw a negative in there. Right, I want negative sine of t dt, so I'll just make that negative. And then since I multiplied by a -1, I will also multiply by a -1 on the outside because it's a constant multiple. And so you can do that, right? You can move a constant from inside to outside. And I can rewrite this now. I have this -1 out here that I made because I needed to make a -1 inside. And then negative sine of t dt, that whole thing becomes du. And then what's left is the secant squared of u. Okay. Now, if you don't like that, if you don't like finding the, saying, oh, I need a negative here, so I'll make one, and then I have to balance it, so I'll also multiply by a -1 on the outside. Another way to do this is, instead of doing that part, just solve this equation right here for dt. You get dt equals 1 over negative sine of t du. You can substitute in for the dt and stuff will cancel. You'll end up in the same spot if you try that. All right, anyway, this is good now. This is an integral that we know, right? We know the antiderivative of secant squared of u du because we know secant squared is the derivative of the tangent function, right? And so this is just going to be negative because that negative is still there. And tangent of u plus c. The derivative of tangent of u would be secant squared of u. So that's right. And we're almost done. We just don't want to leave it like this because there was no u in the original problem. So we sub back in the cosine of t. That's it.